This lecture is going to be about the different plotting systems in R. And over time, R has developed three core plotting systems that vary from each other in slightly different ways and are useful for achieving a few different goals. So I thought I'd talk about the three different systems, what makes them different, and how they're useful for various types of plots. So the first system that I'll talk about is usually referred to as the base plotting system. The base plotting system is the oldest system in R. It came with the original version of R. And the kind of conceptual model that it uses for building plots is a kind of artist's palette model. The idea is that you have a blank canvas, and then you kind of add things to it one by one. So first you create a box with maybe some points in it, and then you add labels, and then maybe you add a regression line through it, and then maybe you add titles and axis ticks and things like that. And so as you kind of piece together this plot one by one, every little piece of the plot takes another line of code or another couple lines of code. And so you kind of add to it one by one. So this is a kind of an intuitive model, because especially when you're exploring data, because you may not know right away what's the plot that you want to make. And so maybe you'll just throw some points on the canvas, and then you'll add some colors, and then you'll add some labels, and then eventually you'll piece it all together. And so this is all well and good as long as you're kind of keeping track of all the code that you use to make the plot. Then you can always reconstruct the plot later. And so the typical mode is for this type of model is to use the plot function. So there's always a function that generates a plot. And then there are other functions that so-called annotate the plot. And these are functions that add things like text, lines, labels, things like that to the plot. So there's the generation, and then there's the annotation. So the nice thing about this system, it's very convenient. It's kind of intuitive. I think many people think of building plots in this manner, but one of the drawbacks is that you can't go back. So if you make a plot and you add something to it, you can't take it away. So it's kind of an increasing process, or a kind of a cumulative process. It's difficult to translate a new plot to another person. So, for example, if you develop a new kind of plot, there's really no way to translate those ideas to another person, because there's no language, there's no kind of conceptual language to use. Every plot is just a bunch of R code, basically, and so that's a little bit of a drawback sometimes. Another drawback with the base plotting system is that because you have so much control over the system, you therefore have to control everything, and therefore set everything very carefully if you don't like the default values. So here's an example, a very simple base plot. You can see what a base plot looks like. And I've used a data set called the cars data set, which shows the speed at which a car is moving and the distance at which it takes to bring the car to a full stop. And so you can see it's just a simple scatter plot with speed on the x-axis and distance on the y-axis. And so base plots look like this. You could add a lot of other things. You could add a title. You could add labels in the plot. You can make the points a different color. You can make them a different shape. There's all kinds of options that you can choose from, and we'll talk about that in detail later. The second major plotting system in R is called the lattice system, and this is implemented in the lattice package. So the idea here is actually quite different from the base plotting system. Rather than piecing a plot together one by one through a series of commands, every plot is constructed with a single function call. And so the most commonly used function is going to be the function xyplot, but there are other functions like bwplot, etc. And so these functions basically construct an entire plot all at once. And so therefore you have to specify a lot of information in the call to the function so that it has enough data to build the plot in an appropriate way. The lattice system is most useful for what are called coplots or conditioning plots, where we want to look at the relationship between, let's say, x and y as it changes across levels of z. And so so the idea is that you're conditioning on different levels of z, and then you're looking at x and y in each one of those plots. These are sometimes called panel plots because you're looking at the same thing in every panel, but just for different levels of a third variable. And you can even combine variables. You can look at multiple factors. So the system is very useful because you can put a lot of plots on a page very easily and very quickly, as long as you kind of follow this conditioning model. And then furthermore, a lot of the details that you would have to specify directly in the base plotting system are kind of calculated automatically. So things like the margins and a lot of the spacings are calculated automatically. And as long as you can accept those defaults, then most things will look quite nice. So the downside of the lattice system is that sometimes it can be very awkward to specify an entire plot using a single function call, and sometimes it seems more natural to kind of piece things together one by one, like in the base system. It's difficult to annotate a plot, especially after the plot's been generated. You can't add anything to the plot. It's done, and if you want to add something, you kind of have to reconstruct the function call altogether. There is a way to annotate each of the individual panels in a lattice plot, but it's very tricky and not very intuitive. You have to use functions like panel functions or things like subscripts, which is not very intuitive. And finally, like I said, you can't add to a plot once it's done. So here's a basic lattice plot. I use some data from the lattice package, and I basically plot life expectancy. So the average life expectancy in a state versus the average per capita income in that state. This is data from the late 60s, early 70s. And then I condition on the region of the country that the state is in. So the country is divided into 4 regions. And you can look at the relationship between income and life expectancy by state across states by region. And so you can see that this type of panel plot is just a single function call in lattice. I use the xyplot function, and it's very simple to construct, whereas something like this in the base plotting system would involve many different lines of code, and it would be much more involved. So the last system, plotting system that I want to talk about is the ggplot2 system. So this comes from the grammar of graphics, which lays out a set of principles for kind of plotting, and creates a kind of language or grammar for describing different aspects of a plot. So it's based on a kind of a well-grounded, kind of rigorous theoretical system, and it's been implemented in R in the ggplot2 package. It kind of splits the difference between the lattice and the base package, so it mixes ideas from both. So on the one hand, you can kind of build a plot incrementally by adding things one by one. So that's kind of like the base system. On the other hand, a lot of the kind of aesthetic calculations are done automatically without you having to directly control. So things like spacings and labels are all kind of put in the right place. So that's kind of like the lattice system. The ggplot2 system is very useful for conditioning plots, just like in lattice. And so you can make those kinds of panel plots. And the ggplot2 system has a lot of defaults. And if you can accept them, it's quite handy. But you can always customize them if you don't like what the defaults are. And so if you know how to use the lattice system, the transition to ggplot2 is not too difficult, although there are some differences that I'll talk about in the lecture on ggplot. So this is a typical default ggplot2 plot. Here I use the miles per gallon data set from the ggplot2 package, and I'm plotting on the x-axis the displacement, or essentially the size of the engine of a car, and on the y-axis is the mileage on the highway for that car. And you can see that roughly as the size of the engine is increasing, the mileage is decreasing. And so you can see that the ggplot2 package creates plots in a slightly different aesthetic. There's a kind of a gray background with white grid lines. The default is to use solid circles rather than open circles. And so, these things you can always customize if you want, but the defaults are a little bit different than the other two systems. So just to summarize, there are 3 basic plotting systems in R. There's the base plotting system, and which has this artist palette model where you kind of add things one by one. There's the lattice system, which you kind of specify an entire plot using a single function call. And then there's the ggplot2 system, which kind of mixes some ideas from both systems. One of the important things to know when you're using these 3 systems is that they can't be interchanged. You can't use them interchangeably. So if you're going to use the base plotting system, you have to use all the functions associated with that system. Similarly, if you're going to use the ggplot2 system, you have to use all the functions associated with that system. So you can't mix the functions between systems because otherwise the plotting will be confused. And so you typically have to choose a system and kind of go with it when you make your plots. So those are the 3 main plotting systems in R, and then in separate lectures I'll cover in detail how to use each one of them.